Hello, my dear viewers. How are you? I am once again here to tell you some more concepts to evaluate integrals. Three concepts we have discussed in the previous video. Now it is the fourth concept to discuss today. It is exponential function. How we evaluate the integral when it is involved exponential function. The simplest form of exponential function is e raised to power x dx. You know that the derivative of e raised to power x, the simplest exponential function is e raised to power x. Its integration is also same, e raised to power x. If it is in the form e raised to power ax, a is constant, its value may be 2, 3, 4, 100,000, any value. So what will be its integral? Its integral will be the same, e raised to power ax, but we shall divide it by derivative of this function. Ax, the derivative of a. Here it is a plus c. If it is 5, then we shall divide e5x by 5. Like this. E raised to power 2x. To make it more clear, then the result will be e raised to power 2x by 2 plus c. This is the concept for the exponential function to be evaluated in integrals. The next is integration by parts. Which is most important concept in the integration. If fx and gx are two functions to be evaluated in the integral, then what is the procedure to evaluate this kind of integral when two functions are available? We take fx as first function, suppose, then its evaluation is first function into integral of second function minus integral of this integrated function. This answer will be written here. Here is not specific function, therefore we write this integral. Main answer is written here. Into derivative of the first function. Dx. This is the procedure to evaluate the integral when two functions are given here. It is up to you which functions you take the first and the other as second. It depends upon the functions. Like this. For example, x cos of x. First example I show you. X cos of x dx. Then which function must be the first? X must be the first function because at the end here we take its derivative and its derivative is 1. When we put here 1, then this function becomes very simple to evaluate here. This is why we take the simplest function as the first function. If we take the first function as cos of x, then its derivative will be minus sine of x, then derivative of sine of x will be cos of x, then it will be go on changing, sine to cos and cos to sine. And integration will impossible to be evaluated. Therefore, we take the simplest function whose derivative is on decreasing x square. If it is x square, suppose, then here will be its 2x. Then in the next step, x derivative will be 1 and function will become simple. Therefore, this function is taken as the first function. So we proceed as first function into integration of second function minus integral of this integrated function into derivative of first x. Its integral is sine of x minus integral, what is integral? Sine of x into derivative of x with respect to x is 1 dx. So the function has become simplest now, it is sine of x. If we put minus sign here, it is derivative of cos of x. And its integral is cos of x plus c. You are looking that here. It is very simple if you make decision correct. Which function is to be first and which is to be second. It depends upon you, but you must be very clever in deciding the first and the second function. And the other case is in the by parts. The other case is when one function is there which has no integration. Like natural log of x. Natural log of x only has its derivative. Then what we shall do? What should we do in this case? In this case, we take the second function as 1. You know 1 is available here anytime it is multiplying log x, also dividing log x. Therefore, we take in this case when integration of the function is not available and it's only the single function, then we take 1 as second function. Therefore, we take first function into integration of second. What is the integration of this second function? It is x minus integral this function into derivative of first. Therefore, we write x natural log of x minus integral x into what is the derivative log x? 1 over x dx. These x are cancelled with each other. X log of x and 1 is here. Integral of 1 dx will be x plus c. So it has been evaluated now in this connection when only the function is available and it has no integral, only it has derivative. Like sine inverse x, tan inverse x, they are the same functions like this. So we take 1 as second function in this connection. Okay. The next concept is the integration involving partial fractions. There are many types of questions in integration, and some questions are raised that how we come to know that partial fractions are required, and other question will be in which type of question we need partial fractions, and the next question will be why we need to make partial fractions. These questions are to be understood with this example. That is 3x plus 8 x plus 3 into 2x minus 1. In the question, you are looking that in the denominator, there are 2 factors. There may be 3 factors or 4 factors. When you see that there are some factors in the denominator, you think about partial fractions. Partial fractions are required only in those questions where factors are involved in the denominator. Otherwise, there will be no solution of such kind of question. The question is that why we need partial fractions? Why we make partial fractions of this question, this kind of question? We make partial fractions of such kind of questions where factors are there in the denominator to convert it into sums like this: 3x plus 8, x plus 3, 1. Next step is multiplying both sides with this factor. We get b into x plus 3. Why we make this partial fractions? Partial fractions are made to change this big function into some portions in sums. That is why we make partial fractions, because integration is easy for these portions. Integration is not easy, not possible in this stage. So we make partial fraction. We suppose here let a equal to 1 and b equal to 2, then 3x plus 8, x plus 3, 1 oblique x plus 3 dx, 2 oblique 2x minus 1 dx. Then the integration will be natural log of x plus 3, because its derivative of the function is here 1. Also 2x minus 1 plus constant of integration, or x plus 3 into 2x minus 1 plus c. You are looking that here the integration is so easy and you have evaluated it. There is no problem. So when you find some factors in the denominator, your first preference should be to resolve it in partial fractions. We change this kind of big function into some portions and evaluate. This is why we make the partial fractions. I think you have understand about the partial fractions and exponential function and the integration by parts. Okay, we shall meet again.